Good afternoon. Okay, I know I've got the last slot of the day, and I know everyone's desperate to go and have a drink or go and get ready for the boat cruise, but please bear with me for a little bit. I promise I will try not to bore you. There's only so much coffee and beer that someone can actually have before they start to get a little sleepy, and I would like to start feeling those effects very soon. So this is a talk called Introduction to Chaos Engineering. Anyone know the term chaos engineering? A few people, perfect. So my name's Paul Stack. You can find me pretty much anywhere on the internet, like Twitter, Facebook, Instagram, all these, the cool kid sites at Stack72. And I work for a company called Joyent. Okay, Joyent is a small cloud provider, and it is a company that's owned by Samsung. So we do a lot of work with Samsung. Anyone class themselves as a distributed systems engineer? Yeah, I can see some people nodding, okay? We are now in the era of creating what we call distributed systems. And distributed systems have become very difficult and interesting to maintain. And this is actually a diagram from AppDynamics. It's an APM tool. And it will actually monitor the tracing through your entire system if you instrument it correctly. And you can see the different pieces that each application talks to and so on and so forth. What this signifies is that life is becoming very difficult. No longer can we clone a single repository. Excuse me. Usually, we can't go to a company and clone a single repository and have everything running on your dev laptop because you have databases, you have security systems, you have all sorts of multiple applications that talk to each other, different runtimes, different languages, et cetera, et cetera. And it's becoming very, very, very difficult in order to actually test. Can anybody realistically tell me that what they test locally on their development machine is actually what is in production? Absolutely not. It's becoming more and more difficult. I used to work for a company in America, and I will never forget when the CTO told us, he said, we're now in the era where you can split your application. We're going to go microservices. You can choose whatever language that you want in order to do it. And if you build it, you run it. At the end of the 2 years experiment, and I will call it an experiment, we had 112 different services, and we actually had 9 different languages in production. One of them was actually, one of the apps was written in Clojure, and there was only one developer in the entire company who understood Clojure. And of course, that developer left. So we had this application to manage, and it became an absolute nightmare. So distributed systems are really becoming everywhere. And there's so many parts that are disconnected that you need to understand what's happening. Real devs don't test in development anymore. I say that jokingly, but at the same time, I actually say it truthfully as well. We are becoming much more confident that when we test code in production, then it's actually starting to be correct because of the tools and the monitoring and all that we actually do. But the question is, how do we build a complex distributed system and be able to scale it? This is a conundrum in IT right now. This is really difficult, and not everyone's getting it right. I'm seeing so many blog posts these days of saying, I'm going from a monolith to microservice. Well, I'm sure we've all read these. And now we're starting to see some blog posts saying, I'm going from microservices back towards monoliths, because it's becoming very difficult for people to understand what's going on. Netflix gave a great quote. There's many, many, many blog posts out there about this type of thing and about tracing. And Netflix said, the best way to avoid failure is to fail constantly. Now, you can take that in whatever way you want. But to me, that actually means is that they are testing failure and actually injecting failure into their system every day so they can understand what is going on. And thus, this is what chaos engineering is. We're going to try and get through this pretty fast today because, as I said, we all want to go and have a beer. So chaos engineering is the discipline of experimenting on a distributed system. Okay? In order, that experimentation gives us confidence in the capability, and it also gives us confidence that we can withstand production problems. The best people that test our system every day are our users. They will find ways through your system that you did not know existed. And you will be head smacked thinking, how did that bug arrive? And it does happen. Now you can go and you can actually have a read on the principles of chaos. There's very easy. But if you believe that your system does not have a weakness, one of two things is in place. One, you are the best coder ever, and I am actually hiring for my team, so please come and see me at the end. Or number two, you have no idea what's going on in production. You don't have an understanding or a view through to what's going on in production. And I will probably make a rough estimate that it's maybe 99% number two, and maybe 1% number one. Now, there are phenomenal coders in here. There are phenomenal coders at this conference. I'm not saying that that's not the case. What I'm saying is that sometimes we don't see everything in production. Just to show you that I practice what I preach a little bit, I thought I would actually open up our live view of glass into our system. So you can tell me if this is of any use or not. So firstly, what we have is we have graphs for latency our whole way through our system. This is latency changes across different VM creates and different VM describes and so on and so forth. And we have dashboards and metrics that do a lot of different things. We collect about 50,000 streams of metrics, which push on average, if I look and have a view in this test system. So in 7 minutes, we have actually collected 4.8 million metrics. So quite a lot of metrics is being pushed through our system. Second thing, we have distributed tracing for everything. We use Jaeger. I would suggest if you really like a tracing tool, it's free, it's open source. There are lots and lots of other tools. I'm not saying this is the only one. And we can actually see a great distribution of what happens through our system for VM creates. We can see actually here, in this part, we had a small downtime. This is in our test system, by the way. This is not our production. No customers are affected by this. And I got an alert just before I came into the talk today. And the last thing is we actually log everything through logging. Okay? This is a debug logger that we push all metrics to and all queries to. And we can actually see when deployments are happening. We can see when VM creates are happening. And of course, we can actually see when logs are happening and errors are happening. So understanding what is going on in your system is extremely important. If you take nothing away from this talk, take this. You need to understand what is happening in production. It's extremely important. I've lost my pointer. There we go. So there are different layers of our system. Okay? Hands up, full stack developers. Hands up out of those full stack developers who works in hardware, who works in network. I'm joking, I'm trolling. Okay, what I'm trying to suggest is that the job of a system isn't just within the developer realm. Okay, it's in the operator's realm, it's in QA realm, it's in hardware realm, it's in networking realm. It's everybody who has to work together as a team in order to understand the operations of a system. And because there are layers of our system, we can inject, or we can have chaos in any of those areas. So, for example, I have been woken up many times throughout my last few years of on-call where my application is down. But it's actually not the application that's down. It's a problem in the hypervisor. Or it's a problem in the network, and it's actually surfacing itself in the application layer because of latencies and so on and so forth. And we didn't have the correct monitoring in place, therefore the wrong person was woken up because we didn't have that view of glass through the system. So it can happen at any layer, really it can. And because there are so many layers, we can test the injection of chaos into any of the layers. So for example, let's think of network. Okay? What we can actually do is we can test network latency in our system. We can inject network blocks, or like the equivalent of security group rules, which block all access to everything in Amazon or Azure if you're in there. And you can actually see how your system responds because you're actually testing what happens when your application cannot talk to all the different pieces. Hardware, it's a bit drastic, but you could go and you could press the plug on the server and see what happens if you really want. Database, you can run ACLs that allow everybody to go in and SQL inject your database and see how your application reacts. You can test any of these layers. Please, Jesus, please do not run ACLs in production that allow people to SQL inject. I do not want to be sued for telling people to do the wrong thing here. But because of all these layers and we can inject chaos, we need to know what the principles of injecting that chaos in. You cannot just click a button and not understand what's going on. And you can't just click a button and just throw pieces of information to your system and hope it's going to be okay. You need to have a process of understanding it. There are 4 principles. First one, we define a steady state. Number 2, we hypothesize that the steady state will continue. Number 3, we introduce events to mimic what we can do in the real world, okay, that will simulate that there's a problem or an outage. And number 4, we try and disprove that our system is continually working as expected. Now, that's very wordy. Let's give you a real-life example. We often run applications that talk to databases or message buses or any of these things, okay? So that's our steady state. Our steady state is when our application is running, it is connected to our database server. Great. No problem. We know that that's the case because we have tools in place that allow us to see that that's always connected. Number 2, when the database goes offline, we predict that the application will not be able to function correctly. Great. Very simple, very easily. Number 3, we now introduce an event that does that. And how we do that is we will introduce a security group rule, for example, that stops the application server talking to the database server. Just a very simple rule that we can put in place and we can reverse very easily. And number 4, we run the experiment and watch what happens. So what do we expect to happen? The hypothesis says that when the database goes offline, that the application should go offline. If it doesn't, great. Brilliant. You've built a better system than you expected, and you've proved yourself wrong already. If you are correct and it does go offline, then what you can do is you can try to plan around that failure by going into like basic mode of your application, where you serve a front page UI that lets users know that your application is currently offline, you know, and you're not throwing 404s or 503s. That's like the worst thing that you can do for a user. And that's what this does. You can break it down into its very simplest component parts by introducing very small experiments in that way. You do not have to go Chaos Monkey full scale. You really don't. Your company will not enjoy that straight away, I promise you. But of course, we cannot do this without monitoring. We really cannot. If you cannot prove that your system is currently stable, then for goodness sake, do not try and make it unstable, because you don't know what you're going to do. When I say monitoring, I mean there are 4 levels of monitoring, okay? Of course, we have system availability. That's pieces like making sure our application servers are running 200s, making sure that we have the correct systems working as expected. We have system metrics, making sure our CPUs are at our appropriate levels, memory units appropriate levels, message throughput through our system is as expected and not standard deviations above and below, because that's an anomaly that we need to alert on. Number 3, user metrics. If you have an application that you have users logging in or registering, you want to collect those metrics as well, because you want to know that on an average day, 200 million users log into your application. And then if the next day 50 million users log into the application, and the third day back to 200 million, you kind of got a little problem there. You kind of need to know the seasonality and the patterns of user metrics and behavior through your system. And the last one, which is actually the most important, service-specific metrics. So for us in the cloud industry, if we need to know that the creation of a VM should take 2 seconds, if that goes from 2 seconds on a normal day to 15 seconds, then we have a big problem, right? And the poor guys in Azure had this a couple of weeks ago where they had this outage because of weather. And of course, they collect these metrics and they understand these metrics, but you need to know these metrics, otherwise you have no idea. And the worst thing in application development or operations is your users telling you there's a problem before you can see it. It's extremely embarrassing. There's an entire book about this. Okay, we are beyond the era of putting Nagios on servers and collecting memory, RAM, disk, and understanding and making sure that's the only metrics we have. We need to know much more how things work. For example, if your application server is filling disk up and you just get an alert, you want to know what's the rate of change that disk has actually filled. Is it 1% in the last month? Because if so, your capacity planning is pretty bad. But if it's 80% in the last 6 hours, you know that there's a potential problem in your system, and you need to actually act on that before it causes problems. Check the book out. It's very good. I promise you it'll introduce a whole new era of monitoring into your system. Now, let's talk chaos engineering again. Chaos engineering came out of Netflix. Netflix are like the nirvana of DevOps companies to work for, in my opinion. Companies like Netflix, Etsy, Google SREs, and so on and so forth, they've been trailblazing this for a long time and many, many years. And this actually started in 2008. Okay, this is not new. This is like everything in technology. We had the very early adopters. Now we're having the mass adoption. And later, in another couple of years, you'll have the bigger organizations, the bigger enterprises, because they're a little slower moving, will be able to adopt these types of things then. It was started in 2008, and they actually called it resiliency testing. Chaos engineering is a newfangled term that is actually kind of cool, and it makes you want to do it. Who wants to put on their CV and their resume, I'm a resilience tester? It's like, I apologize, this is a small jibe. It's like putting DBA on your resume, right? Nobody wants to be a DBA anymore. Everyone wants to be a full stack developer, a distributed systems engineer. But it's made it sexy. It's made it a little bit more, chaos, that sounds a bit weird. But at the same time, it has also put it in a place where most people go, sounds dangerous. If it's dangerous, I can't do it. But it's not dangerous. If you take it slowly and adopt it small, and sell it, then you can actually be very successful at this. Does anybody know the Simian Army? This is the open source suite of tools that Netflix have created. Now, since 2008, lots of tools have come up. Okay, the first was Chaos Monkey. I'm sure people have heard of Chaos Monkey. Okay, Chaos Monkey is an instance-based tool. Okay, this is a tool that will act specifically on instances, specifically on application groups or scaling groups, or if you're in Azure and there was the same equivalent, it would be like scale sets. Okay, it's at that level, instance management. Okay, the next one was It's important to say here, Netflix were very specifically in Amazon, so their tools were designed for Amazon topology. Okay. Instances sit in what's called availability zones, and there are usually 2 or more availability zones in a region. Okay, a region would be US East 1, or EU West 1, or US West 2, or so on and so forth. It's a geographical location, and inside that there are a number of data centers that map to be availability zones that you can put your systems in. So what they wanted to do is, when they were confident enough that they could test that application servers could withstand problems, next they were like, right, we really need to start testing when we lose entire availability zones. Okay? And they developed something called Chaos Gorilla, okay? Because Gorilla is a little bit bigger than Monkey, and they can actually inject more chaos into the system with a Gorilla. Now this is really good, because if you're in the cloud, you do have to plan your architecture for the cloud. So for example, if you have a database cluster of 3 servers, you would not put all 3 servers in one availability zone in a region. Because if that region goes down, you've lost everything. Okay? You would plan for quorum. You would put 1 in each availability zone, or as many availability zones as you could, and that way you're able to withstand an outage, a single availability zone outage. Now, I'm not saying that only ever one availability zone goes down. Of course, there are disasters that happen that take out entire data centers, as the as I said earlier, about the ops guys had to deal with Microsoft a few weeks ago. So Netflix decided that we should test for that as well. We should test for entire regional outages, and they developed a big tool at the back called Chaos Kong. Okay, and that will actually simulate that an entire region in Amazon goes down and that they can fail their entire system across into another data center. This was really good in a few instances. About 3 years ago, there was a huge outage on US East 1 in AWS. Anybody who knows AWS knows that US East 1 holds IAM and S3. And if you lose IAM, you lose a lot of your system. Okay? So what Netflix used to do is they actually used to practice failing over from one from one region to the other. And they were actually able to withstand an outage for less than 7 minutes, which is seriously impressive for the size of organization they are and for the size of user base that they have. They are not the only people doing this. They really are not. Okay? Uber, Dropbox, Google, Amazon. You can read new case studies every week of new companies introducing this into their system. Banks are now starting to introduce it into their system. The newer banks, like Monzo in the UK, for example, not the more traditional banks, because they're a lot bigger organizations and it takes a lot, there's a lot more layers they sell through to the top level. But Uber do it due to an outage in replication of their master logs, killing their primary database. So they lost S3, so therefore the logs actually failed to be replicated away from their primary database, and at that point their database server filled and filled and filled and filled and filled, dropped over. Okay? Dropbox did it because of master replica pairs in their database cluster bringing down the Dropbox site. Google and Amazon have been running disaster recovery tests for longer than anyone else. They didn't even have a name for it. They just called it disaster recovery testing. Like we usually have a disaster recovery document, but who actually tests it? And there are so many people practicing this now. There really are. Look at any major system outage in the past, and I can pretty much guarantee you those teams will be trying to work out how they can do better and how they can avoid that from happening again. I know it's sometimes a very harsh lesson to learn, and I know sometimes it takes a very bad event in order to make our practices better, but one bad event is better to be survived than 5 bad events. You always must be trying to get a little bit better to save your life. System failure happens every day. It really happens every day. If you go through an entire day without something going wrong in your system, as I said, I am hiring. And it's really important that I get your resume because I need people who build systems like that. 99.9% of developers, it's human error. We are not robots. We are not designed to cut the most effective code, the best performing code, the most understanding of computer algorithms in order to make it as fast as possible. Okay? We have to start somewhere and we progressively get things better. And until that happens, unfortunately, system failure happens. I know one of my favorite stories of a system that I actually broke. I'm not going to say the name of the company, but again, it's an American-based company, not my current employer. It's important to say. I argued with the CTO. He put a production freeze a week before New Year's Eve, and it was a reservation system. I'm not going to say the name, but there are not many of them in the world, in the area that I worked in. And he said, we're putting a production freeze in place for the week before New Year's Eve. I argued and argued and argued, and I said, production freezes mean you have no confidence in your developers. He was like, okay, let's lift the production freeze. I took the entire system down on New Year's Eve, the entire system. And it was down for 9 hours. Now, of course, I had to then explain to the CTO why I was making a deploy in the morning of New Year's Eve, and my response was, I'm young and I'm stupid, and I wanted to show that these processes work. And he said, well, it's a very important lesson to learn. You have to be pragmatic with what you're doing. And I totally understand that now. But it's only by trying to understand what's happening in your system can you make it better. Nobody likes to be woken up at night. Nobody. If you do, you're kind of weird. There are a lot of tools starting to spawn from the back of this. Okay, this is one of them. This is called Chaos Toolkit. Okay, Chaos Toolkit is an open source product that's on GitHub, and it's created by a company called Chaos IQ. Okay, and I will show you a demo of this in practice very shortly, and you can go and have a look at what's doing it. There's a paid-for tool called Gremlin, very well-known SRE who used to work at Dropbox. She now works for Gremlin, called Tammy Butto, and she's primary SRE, and she's doing amazing things in the Chaos community. And this is she's really driving this product forward, which is fantastic. And this will actually inject Chaos into your system, and it'll monitor everything that's there. It's like an all-in-one product, and that product has dashboard, has systemd, and everything like that built in. But we're going to demo Chaos Monkey, okay? Just because it's actually a fun demo to give. And we'll show some stuff. Anybody any questions so far? Anybody just want me to shut up so we can go for a beer? Perfect. Now, let me show you what I've done. Come on. So, just before this talk, I spun up an autoscaling group in Amazon. I'm sorry, but my demos today are Amazon specific. Later in the year, I will be speaking at an Azure-based conference, and I will give similar demos specifically for Azure, but I haven't written them yet. So I thought it's best to show the ones that I have written. So I spun up an autoscaling group with 20 instances on it. Okay? So we're just going to pretend that we have a 20-instance cluster of our application, and we have a lot of users going through it. I am going to use a command line tool on my Mac called Chaos Monkey, CLI. Okay, it's an open source product as well. And lastly, I have a server that I spun up. And no, you cannot log in because it does have access. It doesn't have a username and password. And in here, I have a Gradle application, which is actually the live instance of Chaos Monkey. Okay. And I can show you Vim, excuse me, cd Chaos Monkey, Simian Army. And I can show you Vim. I can show you the properties of it. Firstly, let chaos run true, which is the most important thing, because we're actually going to destroy some instances today. And we want to enable on-demand instances to be destroyed. And we don't care if anything inside our autoscaling group is destroyed. And the probability will be 1. Therefore, every command I throw at it will destroy an instance, because that's what we like to do. And you can start to go the whole way down through it. The most important thing is here is you have some strategies. These strategies are extremely important because, excuse me, I'm sorry. These strategies will allow you to test different pieces of your system. So the first one is shut down instance. We want to be able to test that when we destroy an instance, that a new instance comes back in its place. Okay. Second one is if there's network problems, we want to make sure our network. Third one, burn in CPU, making sure the system or the application can still cope if the system CPU is like over 100%, and so on and so forth. You can turn these on and off as much as you want. Okay. And there's lots more. There really are. You can go the whole way down. Now there's a very interesting one right here that I have my cursor on. Mandatory termination. Okay. You can actually set Chaos Monkey to mandatorily kill off each instance in your cluster in a specific rotation. Okay, so for example, every 32 days you want to kill all the instances of your system. So it'll throw a request. The 0.5 probability is 1 in every 2 will be destroyed. So you'll actually rotate the entire cluster as you go through. And you can actually do that and check the whole thing through. Now this was very interesting for me because about 2 years ago I worked at a startup that funnily enough went bust, as startups do. I promise it wasn't due to what I was doing here. I used to have an application that's called Rundeck. Okay, Rundeck is an open source operations tool. And every 7 days, We used to rotate the entire cluster of servers and destroy them one at a time. So at any one point in time, our servers were only 7 days old. Now, you're probably thinking, what's the point? What is actually the issue there? Firstly, we introduced security patches at a maximum frequency of 7 days, which was pretty nice. Secondly, we destroyed any manual tinkering on the boxes every 7 days because developers are weird. Developers like to touch things. Developers like to go into boxes and SSH in, remote desktop in, and toggle that on, or change this setting, only because of the fact that if they go through the operations team, it'll take 2 weeks. So what do? We SSH in and we change it, and then our application works. We are weird people. We don't follow rules. We are not robots. So therefore, you can actually get this system, and it will run over your entire system day by day by day by day by day. And the interesting thing is, the guy who wrote this tool, this person right here, he actually has a blog post about this, that he runs this right now. I can't remember the name of the company he works for, but they have a HA proxy configuration over the front of their Chaos Monkey instance, and they can just log in and actually see what's going on. And it's just running publicly against their production server every day. And I find that fascinating that he blogged about that, because that is a big security risk. I'm telling people that you actually have a Chaos Monkey endpoint in place. But anyway, so there's a lot of interesting things that you can do with this. And as I said, this is very specific for Amazon. There are tools available for Azure, and we'll look at some of the things that's available. And the last thing is that you can send notifications. Maybe you don't care when chaos happens in your system. Maybe you really don't. Maybe you're so far down the line that your system is so resilient that if an instance dies, you don't care about, you trust that Azure or Amazon will replace that instance, and you trust that your application will recover as expected, and it will bring it back into the loop, and it will serve requests. But when you're getting started, you probably want to know when experiments have happened. Now, in a last talk I gave, someone said, can we set a schedule for chaos? Just think about that for a second. Can we set a schedule for chaos? And it was a fair question, because it was their first foray into chaos testing, and they wanted to do it outside of normal work hours. And I sort of suggested that's not really chaos testing at that point. That's just going back to like straight resilience testing or application-based testing. But it got me thinking. You can set time periods for this. I am not going to say that that's a bad idea if you set a time period, because it will take you some time to get up and running with this. It will take you some time to sell it to people within your organization, because it really will. You tell your CTO or your boss or your line manager that you're going to destroy a production server 50% of requests that you make to Chaos Monkey every day. He's going to go, or she's going to go, nah. No. We do that in testing or in the QA environment. So it's maybe good to set some rules and some boundaries about when things happen. And it's also maybe good to show some notifications that it has happened for 2 reasons. One, it will introduce a little bit more confidence that an event has triggered, and look, the system didn't fall over. Okay? Or 2, an event has happened, shit, the system has fallen over. Because it will ultimately be the case. So let's actually run some chaos. I told you I have this tool. So Chaos Monkey will look at what's configured in my chaos environment right now, and it will show me today that I cannot connect to anything. Oh, if I actually put the correct port. Whew. Demo failure, wow. Okay, and you can see I've actually been running tests this afternoon. I thought it would be kind of professional if I tested my demo a little bit and not have a failure that I just tried to have right now. And it's like a very simple trigger a burn CPU, trigger a fail EC2, nothing crazy, okay? So I thought, let's look at what's going on in the system, and let's run the following command, okay? Hit my chaos endpoint. This is a publicly accessible endpoint. Please do not make a request on your behalf or my behalf if you have a laptop right in front. it may destroy my demo. Okay, so I'm going to talk to the auto-scaling group, TFASG. I specifically made it difficult because somebody did try and attack my Chaos Monkey endpoint during a talk. So I'm going to try my best and not let that happen. Okay, and the strategy I'm going to use is I'm going to shut down the instance, and I'm going to run that command 10 times at an interval of 60 seconds between each command. Okay, so I can now make the hypothesis that 10 machines will be destroyed in a 10-minute period, and Amazon will replace them to bring it back, the system back to 20. So let's just run that in the background, and we'll see. First one's shut down, or excuse me, the first one is test is underway, and if I refresh, I should see the first application is shutting down right there. And if I go back to my Chaos endpoint, it'll give me the log output in a second because the process is running in the background, and I can tell the logs to find out what's going on. It will tell me the instance is shut down, new one spun up in its place, and it's keeping it more importantly. Now, if I go back, and if I Chaos, I go to the endpoint, you'll see a new one just happened at, time zones are crazy for me. This one right here, 8:15 in the morning in London, or in, excuse me, UTC. So we can see a new one has happened in its place, and a shutdown is in instance right now. And in 60 seconds, just because that's how my auto-scaling group is set up, Amazon will start bringing a new one up. Look, there's a new one shutting down. So my system is like starting to be under pressure. First instance is down. What's going on? Second instance is starting to go down. It's like, wait, Amazon hasn't brought any new ones up yet. And if I go into my auto-scaling group, Amazon's going to tell me, should tell me very shortly, that there are some problems with instances. And it will show me the life cycle of some instances is starting to be affected. So it is going to happen in the background. It takes, I think, my service is configured for a minute, excuse me. And it'll start to replace them in the background. Let's just go and see if it's going to spin any up yet. Not quite yet. So we can let that run in the background and see what's going on. Now, let's have a look at the open source tool, okay? As I said, Chaos Monkey specifically for Amazon. So let's look at something a little bit more agnostic, platform agnostic, to show actually what's going on. And let's have a look at like a tool that's designed specifically to fit the principles of chaos. Okay. So the first one is terminate the database master should not prevent the application from running. Exactly what I told you the example was. Okay. Description is there. Steady state hypothesis is currently all systems are available and healthy. Database cluster is up, application cluster is up, health endpoints are working, status endpoints are working, everything's returning normal amounts. Okay, we are going to terminate the DB master. We're going to probe that the DB master has actually gone down. And we're still going to probe at the end that the application server will continue running. Okay, now it looks weird. And if I refresh, we will see. Let's run the experiment, terminate the DB instance. We validate it. Everything is currently looking good. The system is running as expected. Let's wait for while the application or the DB master is being terminated. Let's wait for 20 seconds while it's actually going offline. Shut them down, draining connections, etc. As soon as this happens, very shortly, I promise. Come on, 20 seconds it's waiting on. There we go, probing, we're still fetching database logs. Lastly, we're checking that the application is healthy and alive, and then we're actually getting a pass to say everything is working. And that experiment can run and run and run and run and run and run every day, run every week, every year, whatever term, whatever period that you want it to actually run for. It's written in Python. But it's not specifically for Amazon. It's not specifically for Azure. It's not specifically for GCP, and so on and so forth. Now, there are current drivers in place for these tools. And if I go to the drivers, browse the extensions, we can see there are Kubernetes. It's so popular right now. Like, people are building this in from the start. Amazon, there are endpoints that people building for Amazon. There is Azure Service Fabric, which is awesome to see Azure starting to come in here in the open source world for the Chaos endpoints, because I know there were some things internally for them. Humio, which is the application we use, things to do with Cloud Foundry, Google Cloud Engine activities, Prometheus activities. There are lots and lots of drivers. It's open source. You can take it, you can write your own drivers, your own extensions, and you can start to run your own experiments. And it doesn't have to be terminating your database. It can be as simple as terminating a security group rule, okay, or adding a new security group rule, making sure your system can still work as expected. Okay, it can even be lower level than that. Fill your database EBS drive or your EBS volume, and that way that your system can still work. Second one, cut off the security group that ships your logs from your local disk to your log server. Okay, you can start really small and you can start to really understand what's going on in your system. Let's go back to Amazon and find out what's going on here. So we can see 2 servers are currently destroyed. And we can see that there are still, this is an application server that's currently being replaced in its place. We can see this one's an application server that's being replaced. So the experiment is running, the experiment is going through, and it's killing our applications servers, and it's bringing them back up. And we can go and have a look at how many it's done. So currently it's done 7 instances, and it'll just keep going through and through and through and through and through. Now, if you want to not cheat and destroy every instance, then there is another command that you can run. This one is slightly different. Okay, so again, we're going to attack the same autoscaling group. We're going to run it 5 times at a period of 10 seconds. And the probability of a destruction event is actually only 0.2. So 10%, or excuse me, 10%, 20%. Okay, so only one out of our entire cluster, in this case, will actually fail, or excuse me, will actually be destroyed. So therefore, this is a much less risky experiment to run. The last one I'm running a probability of 1. So you can start to tinker around with what's actually going on and how many times a day Chaos Monkey is running, or whatever tool that you choose, in order to understand what's going on in your system. Any questions? No one care? Just a quiet room? Perfect. Oh, excuse me. There are lots of resources. Okay, so the first one I showed you is Principles of Chaos. Okay, there is a whole community around this. There's a Slack organization. Okay, there's lots of very good community curated information as well. Lots of GitHub repositories that you can go and visit, you can see. And then the last one, of course, is you can go and visit how Simian Army works in order to try to understand what's going on in your system to try and implement those practices. There is also, of course, like every good technology, a conference around it. Unfortunately, the conference is next week. Okay, so it's going to be, unless you're in America, it's going to be pretty difficult to get there next week. But there are some amazing people running keynotes. So like, for example, Adrian Cockcroft, who now works at Amazon, or AWS, and who used to run engineering at Netflix and was one of the forefront peoples of how to do this. Okay. Also, Jessie Frizzell, who works at Microsoft, who is the queen of container security and understanding about chaos of containers and stuff like that. There are a lot of people who are going to engage with this ecosystem and this community in order to drive the best out of what you're actually doing and understanding what's going on. More importantly, sharing is actually giving other people ideas about how to test within your environment. It's very difficult to go away, sit in a room with other people who don't have any experience in this area and try and design chaos experiments. You must be speaking to people. I'm not specifically saying you have to go to conferences designed for it, but you must be speaking to people who have experience in this area, who have designed these things with mind. and in mind. Okay, just this morning, I was working before early while I had a call, and I was actually jotting down some chaos experiments that I was thinking about for what we're building. We're building a new VM create piece. And I'm thinking, how can we actually build an API that's an internal API that we have a tool that just runs every single day and every single time? And one of the tools I can actually show you that we have done is, so we want to test that our cloud is actually able to, I showed you the metrics, these metrics right here, of how we're able to see that all the VM creates are actually happening, and that they're happening within this specific amount of time. So what I thought it would be quite good to do, this is not open source, I'm afraid. But we have an application which we call VM Canary. Oh, wrong one, no. VM Canary, and so it's a little application that just runs, and it runs in concurrency levels. And it's running inside we use an application scheduler called Nomad. So this is always running. It's always firing VM creates. As soon as it runs a create, it runs a select, it runs an update, and it runs a destroy, but it runs parallel requests at the same time. We can fine tune it. Again, I thought it would be interesting to show you how we actually configure this and fine tune it. Nomad jobs, VM Canary. So we can have back-off periods, we can have concurrency levels, we can do all the different pieces that we actually need. So we are building tools into our system as we are designing this new feature that will test resiliency of our system. Of course, I'm working on a greenfield app, and it's all very nice and very easy for me to start building that in. And some of you are sitting out there going, well, I'm working on a 15-year-old application that's like 1 million lines of code. Okay? You can start. This is like, I'm not comparing it to these things. It's like when you started continuous integration for that project, or continuous delivery for that project, or added all these monitors, or you were starting to do DevOps for that project. You must start small. Start at the very smallest component, this piece that is going to cause least concern, and use that small piece in order to grow confidence within the system. Next time you have a hack day, for example, spend 2 hours or 3 hours or an interesting couple hours actually trying to design a chaos system for your environment, for your test environment to start with, not production. Don't go for production to start with, please. Please. But you can really start to do it, and you can actually start to leverage some tools, and it's very simple. So for example, you have a very simple CLI app that you run as a service or a batch job, and all it's doing is it's firing a delete request at your API. That's a simple chaos test. It's as simple as it gets. You haven't needed to use or buy a tool. You've written something in a very short period of time, and you're actually getting immediate confidence in your system, and you're getting an immediate value add for your system, because ultimately that's what we want at the end of the day. We want to add things on that creates value for our customers, to let our customers know that we're trying to do the best things for them. A great example would be, and I only say it because I'm in Australia and I remember, Troy Hunt. Troy is one of these people who finds, by way of social media and so on, all of these different systems that don't have SSL certificates, for example, right? And there are lots of them out there. Wouldn't it be really good if you could run a chaos experiment that actually changed your certificates, okay, in your test environment, again, not your production environment, that changed the validity of your certificates, or actually like deployed the wrong certificate, changed the key of the certificate, because certificate management is a problem. It's not something that's easy to do in different platforms, and we do make mistakes. So again, we have Sarconis inside cloud, and we actually have a rule set that checks for certificate end dates and checks for certificate errors. So we can actually start to mess around with certificates. We use Ansible for certificate management in this way. So we can run an Ansible command that deploys the wrong certificate to our test server. Our monitoring system should pick that up straight away and alert that that's the case. So we should be able to straight away, our hypothesis there is that we should get an alert we should have a severity 1 because it does affect customers and does affect security. So therefore, the remediation is we need to fix it straight away, and that must happen within an SLA time. And if it's in the middle of the night, somebody must be woken up. So it's very simple experiments like that. Okay? And you must start off with monitoring. Monitoring and metrics are the most important part. And I can show you this exact metric. Integrations checks. If you just give me 1 second. These metrics are firing right now. We can see certificate end in seconds. It is actually there. The value just hasn't been calculated. In fact, let's look at the metric. We can see certificate end in seconds is like 1.5 million or something like that. So we have an alert in place that says when the certificate is within 7 days, send severity 2. If no one has actually fixed up that certificate, if it's at 6 days, another severity 2. If it gets to 3 days, send the severity 1. If it gets to 1 day, alert the entire engineering part of the organization. Because it's really important, it's really to understand when certificates are a problem, when certificates are an issue. So we're starting to build our own chaos tests in from the start. The one piece of advice I give you, join the chaos community. It's a Slack organization if you use Slack. There are lots of useful people in there who you can talk to who do this at scale, really at scale. And you can tweet me if you have any other questions. Thank you so much for your time and enjoy the boat cruise tonight if you're going.